Look at this red ball. You've been taught to call this a particle, something solid, but according to our very best physics, this particle doesn't exist. What you're actually looking at is a disturbance in something deeper and invisible that fills every inch of the universe. Welcome to the world of quantum field theory. Today we're going to use a simple analogy of a lake to begin to explain why fields are the basic building blocks of our reality, and then to answer the question, what are particles if they're not solid? Are fields more important than particles? Ignoring the maths, let's start with a simple definition.
Fields are defined something like this. It's a volume of space where a force can be felt under the right conditions. We talk about magnetic fields, gravitational fields, and electric fields. So we might, for example, say that if you have a positive charge here and you're being a negative charge there, then there'll be an attractive force due to the field. My questioner asked, what is a field made of? The preposition to that being that everything is made up of something, so physical matter creates more physical matter. So we have quarks that make protons, that make atoms, and so on. But the premise of this question is wrong. Currently, the theory known as quantum field theory would suggest that the particles are less fundamental than the field. In other words, think of the field as being like the bricks in a house. The bricks are more fundamental to the house than the rooms are, although you probably don't think about the bricks much when you're in the rooms. Somehow, mysteriously, the particles are created within this field when there is a disturbance in the field. A lake is a good picture, although of course not a perfect one, of what people understand a field to be now. Quantum field theory suggests that there are a number of fields which spread out uniformly across the whole of space and maybe time as well. And these fields can be pictured as being somewhat like this lake, i.e. beautifully calm and flat. We can take the analogy with the lake as being a field a step further. What happens if we throw in a stone is that we get ripples on the pond. I mean, that's obvious, isn't it? In the same way, if we get ripples or disturbances in one of these fields, then according to quantum field theory, that is a particle. In other words, this is how a field is in fact more fundamental than a particle. That stone, as it hits the water, creates ripples which spread out, which can be thought of as being the particles, although it's probably better to think of the ripples as disturbances rather than symmetrical, round, circle things as spreading out from a point. Quantum field theory further suggests that every type of particle can have a field. Now, there are some differences of opinion on this. Some people suggest there are only a few fields, whereas others would suggest there's one for an up quark and one for a down quark, and so on and so on. Either way, particles can be considered as being tiny little localized vibrations within those fields which spread out through the whole of space and time. Thus, space is full of these fields spreading out in all directions, and these fields are full of tiny localized little vibrations that are the particles. And just as you're used to the idea of the notes, say, from two guitar strings interfering to create a more pleasant chord sound, if you're lucky, so it is that these tiny vibrations or tiny disturbances within the various fields can interact with each other. Thus, the complexity down at the size of the subatomic world is beyond imagining. Because our minds are so highly trained to think in this way of everything being built up out of something else, we can't get past the question that was asked is, what are these fields made of? And the simple solution is, we don't really know yet. So while we've obviously just skimmed around on the surface, if you'll pardon the pun here, what we can say is that the topic of waves, which most people seem to really dislike in physics, is really fundamental to understanding of how the universe seems to work, i.e. we use the word ripples. That's not to say that they're actual transverse waves as you understand them, or even longitudinal ones, but somehow the idea of waves plays into this topic.
If you found that video interesting, why not try this one?